Hello everyone, welcome to our channel. Today in this session we are going to learn LAQ from chemical bonding. LAQ is what do you understand by hybridization? Explain different types of hybridization involving S and P orbitals. Definition of hybridization is the process of intermixing of two or more different orbitals. Intermixing of two or more orbitals of nearly equal energy to form identical hybrid orbitals are called it as a hybridization. In hybridization, how many atomic orbitals are involving? Two or more different atomic orbitals which has the nearly equal energy to form identical hybrid orbitals having same energy. The resultant are hybrid orbitals which has the same energy. The number of hybrid orbitals formed is equal to the number of atomic orbitals intermixed. In hybridization, number of hybrid orbitals equal to number of atomic orbitals intermixed. The different types of hybridization in sp orbitals are sp, sp2, sp3. How many hybridization types we are studying in this session? 3. What are those? sp, sp2 and sp3. See here. This is the hybridization. Example: central atom, ground state electron configuration, excited state electron configuration, and shape of the molecule, percentage of S, percent of P, and bond angle is here, and number of sigma bonds. Is it clear? How many columns are here? 10 columns nearly, I think so. Okay, first one is hybridization. In hybridization column, this is the sp hybridization. What is the meaning of sp hybridization? Sp hybridization means one s orbital, one p orbital intermixed to form sp hybridization. In sp hybridization, how many atomic orbitals are participating? 2. What are those? One s orbital and one p orbital. Okay, this is the s orbital and this is the p orbital. These two orbitals are intermixed to form sp hybridization. sp hybridization. Example for this sp hybridization is barium chloride, and in barium chloride central atom is beryllium. Ground state electron configuration is 1s2, 2s2, 2px0, 2py0, 2pz0. In the first excited state, this electron from s orbital move to 2p orbital. So then first excited state electron configuration is 1s2, 2s1, 2px1, 2py0, 2pz0. Shape of this sp hybridization is linear. Percentage of s character is 50, percent of p character is 50, and bond angle is 180 degrees. In number of sigma bonds are present in sp hybridizations are 2. See here in barium chloride, how many sigma bonds are there? One is here and one other one is here. Okay, is it clear? This is all about sp hybridization. In sp hybridization, first column we should write hybridization. Then example of barium chloride. This is the barium chloride structure. In barium chloride, central atom is beryllium, and this is the ground state electron configuration, and this is the excited state configuration. And then shape. In sp hybridization or in barium chloride molecule, shape is linear, and percent of s character is yes, 50%, p is 50, and bond angle is 180 degrees. Coming to the sp2 hybridization. In sp2 hybridization, what is the definition of sp2 hybridization? In sp2 hybridization, one s orbital and two p orbital intermix to form sp2 hybridization. See here, this is the s orbital and this is the p, x, and this is py. These three atomic orbitals are intermixed to form sp2 hybridization. Example for this sp2 hybridization is BCl3, and this is the structure of BCl3. How many sigma bonds are here? 1, 2, 3 sigma bonds are present in BCl3. So in BCl3, central atom is boron. Ground state electron configuration is 1s2, 2s2, 2p1. In the first excited state, what happened? The electron from 2s orbital, see here electron shifted to 2py orbital. So in first excited state, electron configuration is 1s2, 2s1, 2px1, 2py1, 2pz0. Shape of the sp2 hybridization is trigonal planar. In sp2 hybridization, S character is 33%, P character is 66%. Bond angle is 120 degrees. Number of sigma bonds are here 3. And coming to the sp3 hybridization. In sp3 hybridization, one s orbital in 3 p orbitals intermix to form sp3 hybridization. Not 2 here. 3 p orbitals intermix to form sp3 hybridization. Okay. In sp3 hybridization, the orbital shape is like this. See, one s orbital, px, py, pz. These 4 atomic orbital intermix to form sp3 hybrid orbitals. Example for this sp3 hybridization is methane. See, this is the methane structure. How many sigma bonds are present here? 1, 2, 3, 4. Bond angle is 109 degree 28 minutes. In methane, central atom is carbon and electron configuration of carbon, ground state electron configuration, this one. So 1s2, 2s2, 2p2. In first excited state, what happened? Electron from s orbital move to 2pz orbital. So first existed electron configuration is then 1s2, 2s1, 2px1, 2py1, 2pz1. Shape of the sp3 hybridization is tetrahedral. Percentage of S is 25%. Percentage of P character is 75%. Bond angle is 109 degree 28 minutes. Number of sigma bonds are 4. This is the short notes of hybridization. Okay. Here we covered all points. Instead of writing a long for long answer, you can write like this also. Okay. This is all about hybridization and types of hybridization. Okay. Is it clear? So you should memorize this one. Definition first of all. If you like my video, please like, share, subscribe. Thank you.